uh, is standardizing. So we might want to talk about standardizing the size of the difference between the two means with a statistic that describes the effect size. So one of the most widely used statistics for this purpose is known as the Cohen's d, which is easy. It's easy to computate, so it's easy to do. It's also a widely used measure of effect size. So what we do is we subtract the control group mean from the experimental group mean and divide it by the standard deviation of the control group. So here is an example. So let's say that researcher A uses a scale with these possible score values from 0 to 100, and these were the results. So you see the experimental group has the mean, the standard deviation, the control group has the mean and the standard deviation, and then what you see is that you subtract the control group mean, which is 30, from the experimental group mean, which is 40. You divide it by the standard deviation of the control group, which is standard deviation of 10, and you have a 1. So what we're doing is saying that the Cohen's d equals 1 based on these previous numbers. So what we also are then saying is that the mean of the experimental group is a full standard deviation higher than the mean of the control group. Now, is this large? Yes. Yes, it is actually quite large. So remember that there are only about three standard deviation units above and below the mean, and as you can see on the distribution across this normal curve, the vast majority of the cases, about a little over 68%, are within one standard deviation of the mean. So if the average mean participant in the experimental group is one full standard deviation above the average participant in the control group, we're talking the Cohen's d of 1. The average experimental group participant is higher than the vast majority of those in the control group. Now, let's look at this example, and remember we talked about standardizing. Using Cohen's d actually standardizes the descriptions of the sizes of the difference. So let's use this example and see how that works. So we have researcher B who studied the same phenomenon as researcher A, and but used a scale with scores that range from 200 to 800. So researcher A we had in the earlier example, and researcher B has now used the scale with possible scores values from 200 to 800. And so we have the results of their experimental group, the control group, and we have calculated their Cohen's d. Now, notice that the value of Cohen's d is the same in both examples, even though very different scales are used. So if you want, you can flip back and forth between 153 and 154, and you can see the two researchers' results. Now, researcher A had a 10-point raw difference, while researcher B, as you see, has a 100-point raw difference. But now, dividing the corresponding control group standard deviation into each of the differences, we find that the effect size, which is standardized size of the difference, is the same. We have a Cohen's d of 1 in both of the cases. Now, the reason that this standardization occurs is because d expresses difference in terms of standard deviation units, which usually range from 3 below to 3 above the mean. And so using standard deviation units as a way of looking at differences standardizes the process. So now let's look at how do we interpret a Cohen's d. So we talked about the Cohen's d in each of these examples being a 1.00. Now, while there are no universally accepted standards for describing the value of d, here are Cohen's suggestions. So if we say that the value of d, we do research and we find the value of d at about a 0.20, we would say that was the small. A value of d of about 0.5, about 1/2 of a standard deviation, is medium. And a value of d of about a 0.8 or 0.8 of a standard deviation is large. Now, remember, for most practical purposes, 3.00 or negative 3.00 are the maximum value of d, but also values of d in experimental group, they could rarely exceed a control group by more than 3, but not often. So, if we look at it from Cohen's suggestions, we might then be able to say a value of 1.10 might be very large and a value of 1.4 might be called extremely large. But these Cohen d values are rarely found in social science or behavioral science research. Now, let's look at our table. We have the labels for the value of d. And these are, these actually are really pretty good that he proposed these labels. Now, he originally established them subjectively, but what happens through research is that a lot of times we then find that something someone determined is actually very useful to us. So this might be something worth making sure you have a copy of or learning it. Now, these the labels being discussed, the small, medium, large, very large, extreme large, should not be used arbitrarily without looking at the full context in which the values of d are obtained and what the implications are of the research. So this leads us to two important principles. That first, a small effect size might represent an important result, and a large effect size might represent an unimportant result. Well, let's look at the first, which is a small effect size might represent an important result. So let's say that we as researchers are frustrated by consistently finding values of Cohen's d well below the 0.20 when trying treatments for solving a very important problem. Let's say we're looking at treatments for Zika. If a subsequent researcher finds a treatment that results in a value of about 0.20, this might then be considered a very important finding, even at this low level where the effect of the treatment is small, but it might be of immense importance to sick individuals to be helped by the treatment. And the results might point the scientific community into a really good direction with regard to other treatment or research on the problem. The second principle is that the large value of d, even one above a 1.4, might be of limited importance. Usually this is because the results lack practical significance, and we've already covered practical significance previously. You can also look at the previous section, section 27, for more considerations in looking at practical significance of the research. But we have to look at practical significance in terms of cost, public and political acceptability, and ethical and legal concerns. Now, there are 3 steps for interpreting the difference between two means. First, we have to determine whether the difference is statistically significant at an acceptable probability level, such as a p being greater than 0.05. Now, if it is not, the difference should usually be regarded as unreliable, and we should interpret it that way. Secondly, for a statistically significant difference, consider the value of D and consider the label in the previous table that we just showed you on the other page, 28.1, for describing the magnitude of the difference. And third, consider the implication of the difference for validating any relevant theories, as well as practical significance of the results. Now, before researchers begin to follow these 3 steps, we have to also make sure that the adequacy of the research methodology is considered. So if we've had very biased sampling or inadequate sampling or invalid instruments, such that a test that measures a variable other than the one they wanted to study, or poor research design, leads us to serious questions regarding the validity of these results, and in this case, its consideration of the values of D might be considered meaningless. Now, this actually concludes our lecture series in Making Sense of Statistics, section 28. As always, I suggest that you go back and reread the text, as the lectures do not often cover every single aspect of what is in the chapter.